Chipsets. Here is your same structured, beginner-friendly content for chipsets, intermediate level, motherboard intelligence and control. Introduction. While the motherboard connects all components, it needs a system to manage and control communication between them. This system is called the chipset. The chipset acts as the traffic controller of the motherboard, deciding how data flows between CPU, RAM, storage devices, input-output devices, expansion cards. At the intermediate level, understanding chipsets means learning how components communicate through the motherboard, how data is routed efficiently, how chipset design affects performance and features. Chipsets play a critical role in system performance, compatibility, and expandability. What is a chipset? A chipset is a group of electronic components on the motherboard that manages communication between hardware components. In simple terms, chipset equals controller that manages data flow between CPU and other components. Example concept: CPU, chipset, RAM, storage, I/O. Why chipsets are important. The CPU cannot directly manage all components efficiently. Example concept: too many devices means needs centralized control, means chipset manages. Chipsets reduce CPU workload, organize communication, ensure compatibility, enable system features. Main functions of a chipset. The chipset performs several key functions. 1. Data flow management. Controls how data moves between components. 2. Peripheral communication. Connects devices like USB keyboard and mouse network adapters, audio devices. 3. Storage control. Manages SATA drives, NVMe SSDs. 4. Expansion support. Handles PCIe lanes for GPU's expansion cards. Example concept: chipset means manages data plus devices plus connections. Traditional chipset architecture, Northbridge and Southbridge. Older systems used two separate chips. Northbridge handled high-speed components. CPU, RAM, GPU, Southbridge handled slower components. USB storage, audio I/O devices. Example concept: CPU, Northbridge, RAM/GPU, Northbridge, Southbridge, I/O devices. Modern chipset architecture. Modern systems simplified this design. CPU means integrated memory controller plus PCIe means chipset, PCH. CPU means integrated memory controller plus PCIe means chipset, PCH. Key changes. Memory controller moved inside CPU. GPU communication handled directly by CPU. Chipset now mainly handles I/O. Platform controller hub, PCH. The modern chipset is often called the PCH, Platform Controller Hub. Example concept: CPU, PCH, parentheses, storage, USB, peripherals. How chipset works, step by step. Example: opening a file. User request. CPU sends command. Chipset routes request to storage. Data returned via chipset. CPU processes data. Chipset and PCIe lanes. Chipsets manage PCIe connections for devices. Example concept: chipset means allocates PCIe lanes, means connects GPU SSD. Important note: CPU also provides PCIe lanes. High-speed devices often connect directly to CPU, chipset, and RAM. In modern systems, CPU directly controls, RAM chipset plays a supporting role. Example concept: CPU, RM, direct. CPU, chipset, other devices, chipset, and storage. Chipsets manage storage interfaces like SATA, NVMe, via chipset lanes. Example concept: storage, chipset, CPU, chipset, variants. Real-world impact. Different chipsets offer different features. Examples: number of USB ports, PCIe lanes, overclocking support, storage support. Example concept: better chipset means more features and flexibility. Performance impact of chipset. Chipsets affect data transfer speed, device connectivity, system expandability. However, CPU still has the biggest performance impact. Example concept: CPU equals performance. Chipset equals connectivity plus features. Bottlenecks related to chipset. If chipset bandwidth is limited, slower data transfer, limited expansion, reduced performance in I/O-heavy tasks. Example concept. Slow chipset means I/O bottleneck. Advantages of modern chipsets. Advantages include simplified architecture, better performance, improved efficiency, more direct CPU communication. Example concept. Modern design means faster and simpler systems. Limitations. Challenges include limited PCIe lanes, shared bandwidth dependency on motherboard design. Example concept. Too many devices means bandwidth sharing. Concepts learned. What a chipset is, difference between old and modern architecture, how data flows through chipset, role in storage, I/O, and expansion, how chipset affects system features. Simple definition. Chipset. A controller on the motherboard that manages communication between the CPU and other components like storage, peripherals, and expansion devices. Final summary. The chipset is the communication manager of the motherboard, ensuring that all components work together efficiently. In older systems, responsibilities were split between Northbridge and Southbridge, while modern systems use a simplified architecture where the CPU handles high-speed tasks and the chipset manages I/O. Although the chipset does not directly determine raw performance, it plays a critical role in connectivity, expandability, and system capabilities. Understanding chipsets is essential for learning motherboard design, system architecture, and hardware compatibility.